Boeing's CST-100 Starliner spacecraft is once again preparing to take flight. This will be the third launch of the capsule to date, but crucially, it will be the first time that it carries astronauts on board. Commander Butch Wilmore.
This is a test flight, so when you do test, you expect to find things, and we expect to find things.
And pilot Sonny Williams.
This is where the rubber meets the road, where we are going to leave this planet, and that is pretty darn cool.
Their mission is dubbed the Crew Flight Test. It's a journey to not only reunite these seasoned astronauts with the International Space Station, but also to prove the capability and readiness of the Starliner spacecraft to support long-duration astronaut missions as part of NASA's Commercial Crew Program. This will not be Boeing's first foray into human spaceflight, of course.
In the future, Americans will be thrust into space aboard the world's first reusable manned spacecraft, the Space Shuttle.
In 1996, Boeing acquired the Defense and Space divisions of Rockwell International for $3.1 billion. They're the company that developed and built the 6 Space Shuttle orbiters. That acquisition also made Boeing a co-owner of United Space Alliance, the company that operated and processed the shuttle on behalf of NASA. They've also had a key hand in the International Space Station itself as well.
They are our primary sustainer, and they're responsible for safety of all the equipment they built, plus integrated safety across our entire spacecraft. And so the processes that we're talking about that we use together for human spaceflight have been around. You know, we've had the vehicle now for 25 years, crewed for 23 years.
And now with Starliner, they're preparing to ferry astronauts to and from the International Space Station once again. There's a lot to this story, so we're going to break it down into 2 parts. In this first video, we're going to talk about the history of Starliner, what it is, how it came to be, and how we got to this point here, preparing for the crew flight test. And then in the second video, we're going to talk exclusively about the crew flight test, what it is, the full profile of the mission, as well as the astronauts preparing to flight and the training that they had to go through. But first, let's start with perhaps the most basic question. What is Starliner? The Crew Space Transportation, or CST-100 Starliner spacecraft, is Boeing's design to ferry astronauts to and from the space station. It stands about 5 meters or 16.5 feet tall when combining the crew module with the service module. It has a diameter of about 4.6 meters or 15 feet. The crew module features 12 reaction control system thrusters that can generate 100 pounds of force each. The service module has 28 slightly less powerful RCS thrusters, along with 20 orbital maneuvering and attitude control, or OMAC thrusters, that produce 1,500 pounds of thrust apiece. There are also 4 launch abort engines, which can generate 40,000 pounds of thrust apiece. Spaceflight Now was able to take a look at a training mock-up of the capsule over at NASA's Johnson Space Center.
We use this trainer for different aspects, primarily with the crew training, but we also conduct engineering evaluations as we're making design changes, maturing them, and getting into an integrated system to make sure it works in where it's supposed to. You can see we have 2 seats in place there. Those are seats for our commander, where Butch Wilmore will sit, and we'll have the second seat there for Sonny Williams, who is our CFT pilot. And then we have some cargo in seats 4 and 5 in that lower row, what we call, and that's normally where we would be packing cargo while we have crew in the vehicle.
The seats in this particular configuration of Starliner are focused on the body sizes of Williams and Wilmore for this first crewed mission, but as we learned from Nicole Jordan, NASA's manager of the Commercial Crew Program's Spacecraft Office, they're designed to be quite adjustable. She's been working with these seats for about 8 years.
This seat is built to be just ultimately adjustable. And so one of the easiest ones to see is the seat pan, which is what we call this part here. You can see right here that it kind of has a wide range of adjustability. And you can also notice that as you get taller torsos, the seat pan drops, and that way your eye point is kept the same with respect to the displays. And so you're not changing where your eye point is to see the displays as you modify the seat. And that's only one of many adjustments, but it's one of the easiest to see.
The crew module is designed for up to 10 flights, with the service module designed for a single use. Before the version of Starliner that will fly the CFT mission headed out to the launch pad, we caught up with Mark Sorensen inside Boeing's Commercial Crew and Cargo Processing Facility, where we talked about what the fueling process is like.
We have 3 different kinds of propellants on the vehicle, and then we also have what are called pressurants. So think of the propellants as the stuff that actually goes boom, if you will, and the pressurists push it, right? They allow it to go where it needs to go.
The crew module up top uses hydrazine alongside catalyst beds in the thrusters. Meanwhile, the service module uses a combination of nitrogen tetroxide and monomethylhydrazine.
These are typical hypergolic that everybody uses for this kind of stuff. Very stable all by themselves, but you put them in the right mixture at the right time, they will explode.
To fully understand why the Starliner came into being, let's dive into an abridged history of the Commercial Crew Program.
2, 1, 0, booster ignition, and liftoff of Shuttle Endeavour.
As the Space Shuttle program was drawing to a close, NASA needed its own human-rated spacecraft in order to stop paying tens of millions of dollars per seat to Russia to fly American astronauts on board a Soyuz spacecraft. NASA was paying an average of $56.3 million per seat between 2006 and the launch of Kate Rubins in 2020. The cost per launch rose notably over the years as America stood without its own ride to space.
In order to reach the space station, we will work with a growing array of private companies competing to make getting to space easier and more affordable.
The Commercial Crew Program was born out of President Obama's fiscal year 2011 budget.
Liftoff of Ares 1X.
It would supplant the Constellation program, which only saw one launch in 2009. In May 2010, Phil McAllister, one of the architects of Commercial Crew, gave a presentation on behalf of the Commercial Crew Study Team in Galveston, Texas. In it, he outlined NASA's goals for a new commercial transportation system for its astronauts, one born out of competition.
We used and leveraged a lot of the lessons learned, a lot of the experience of NASA over the years. Again, we've been talking about doing this for decades. So now we're actually doing it and being able to apply those lessons learned going forward. And if successful, we feel that there are significant benefits. This could really transform human spaceflight for future generations.
An initial $50 million of funds from the American Recovery and Reinvestment Act kicked things off in 2010. It was used to fund what was called the Commercial Crew Development Round 1, or CC-Dev-1. Of that, Boeing received $18 million to advance the design of a spacecraft it called the CST-100. The fiscal year 2011 budget came with more money to support CC-Dev-2. That contract awarded nearly $270 million across 4 companies. Blue Origin got $22 million to develop its Biconic space vehicle. SpaceX received $75 million to develop the launch abort engines and life support system for the Dragon capsule. The Sierra Nevada Corporation received $80 million to work on its Dream Chaser spaceplane. And Boeing received $92.3 million to advance the CST-100. 3 other companies received unfunded Space Act agreements. Boeing and Sierra Nevada received an additional $20.6 and $25.6 million respectively by achieving pre-negotiated milestones.
There will be no turning back. Once commercial human spaceflight into low Earth orbit is a robust, vibrant, profit-making commercial enterprise with many providers and a wide range of private and public users. This is the ultimate goal and one that I believe unites us all.
Where there was not unity was concerning the Commercial Crew budget. The original request by then NASA Administrator Charlie Bolden was for $1 billion annually. It was a point of contention between NASA and Congress, especially for those who saw Commercial Crew as a funding threat to the Space Launch System rocket. Here is just one exchange from a March 2014 House Subcommittee hearing discussing the budget for the Commercial Crew program.
The committee would indulge me. I'd ask everybody to think back to my first hearings when I became the NASA administrator. When we started talking about Commercial Crew at that time, we were requesting $1 billion. We requested $1 billion over the next 6 years for a total of $6 billion for Commercial Crew. That was based on my estimate and that of the Augustine Committee that said one provider would cost about $2.5 billion. We multiplied it by 2 and I added $1 billion. So that's how I got to $6 billion. We got 0 the first year. The second year we got $525 million. At the time, we were targeting 2015 for the availability of Commercial Crew. We would now find ourselves months away from launching Americans from American soil, and I wouldn't have to worry about paying the Russians another $450 million. Over time, when I kept coming back to the committee, I said, if we don't get full funding, we're going to slip. I came back finally and said, we have slipped. We now will not have Commercial Crew available until 2017. And we may not have the competition that I need. The committee implored us to down select to 1. We said, please don't make us do that. We need competition.
I think this committee and Congress agrees with you. We don't want to be solely reliant on the Russians for human access to space. I mean, we want to launch American astronauts from American soil and American rockets. And,
Mr. Chairman, as I said before, budgets are about choices. This committee, this Congress chose to rely on the Russians because they chose not to accept the president's recommendation and request for full funding for commercial crew. You can't have it both ways.
Well, we're getting away from that. So, I mean,
we're not away from it yet because I don't have a
continue to rely.
budget.
Congress would once again go on to underfund commercial crew. Of the $848.3 million requested for fiscal year 2015, NASA only received $800 million. But the competition did continue, and by September 2014, NASA pared down the companies to SpaceX and Boeing as the awardees of the $6.8 billion Commercial Crew Transportation Capability contract. That would include the value of up to 6 crew rotation flights each to the ISS.
The Boeing contract award was $4.2 billion, and the SpaceX award was $2.6 billion. Now, I want to make sure people understand that that contract value is for certification, so full-up certification, development, and certification efforts, including within the RFP, we had a requirement for at least one crew demo, like a demonstration flight to the ISS with NASA crew members on it. There's a maximum of 6 missions under that contract value and a certain contract value amount for special studies. So it's those 3 components are all in those totals that I gave you for Boeing and SpaceX.
Through all of the contracts up to this point, Boeing was set to receive $4.82 billion and SpaceX $3.144 billion. For its work on the CST-100, Boeing opted to take over the Space Shuttle Orbiter Processing Facility, which is situated next to the Vehicle Assembly Building at the Kennedy Space Center in Florida. It was converted to the Commercial Crew and Cargo Processing Facility, or C3PF. The space allowed for a staged flow of the work being done on the spacecraft in what engineers would come to describe as a womb-to-tomb facility.
We have the privilege of being on the leading edge of human spaceflight. And frankly, it's one of the most important things we do, it's one of the most exciting things we do, and arguably the most inspiring thing we do for the next generation.
In 2015, Boeing held a ceremony welcoming press and dignitaries to see the C-3PF and the progress made toward the goal of a 2017 flight. It was also during this ceremony where they publicly named the spacecraft.
Please welcome the CST-100 Starliner.
Through the development and testing phase, both Starliner and Dragon faced some setbacks that pushed back their launch timelines. Some of these challenges were highlighted in the reports from NASA's Office of Inspector General, as was the case in 2016.
While past funding shortfalls have contributed to the delays, technical challenges with the contractor's designs are now driving the schedule. For Boeing, these include issues relating to the effects of vibration generated during launch and issues regarding vehicle mass. A change in capsule design to enable a water-based landing and related concerns that the capsule could take on excessive water have contributed to delays for SpaceX.
SpaceX ran into parachute and thruster problems during its development campaign. It had 27 parachute tests, with the final one happening on May 1st, 2020, less than a month before launching its Crew Demo 2 mission on May 30th. For Starliner, back in 2016, Boeing announced the delay of its pad abort test from October 2017 to January 2018, which would ultimately push the uncrewed orbital flight test off of its planned December 2017 date. Teams were finally able to accomplish the pad abort test on November 4th of 2019, and it paved the way for OFT the following month.
2, 1, and liftoff.
A big milestone came with the first orbital flight test on December 20th, 2019. The spacecraft flying on this mission was the third of 3 Starliner capsules developed. The mission began as intended with the liftoff of the Atlas V rocket at 6:36 a.m. Eastern from Cape Canaveral Space Force Station. However, not long after spacecraft separation, an issue became abundantly apparent. There was a problem in the software controlling the internal timer of the spacecraft that caused it to think it was much further in the mission than it was in reality. And that caused it to perform maneuvers at the wrong time and ultimately miss the orbital insertion burn.
You know, we build the spacecraft right here at the Kennedy Space Center, and of course I went by before coming here to address the team. And yeah, these are passionate people who are committing a big chunk of their lives to put Americans back in space from our soil. So it's disappointing for us. But that doesn't mean we're not going to diagnose it, figure out what the right thing to do to go forward, whether it's what kind of next flight test we fly, and keep going.
Instead of docking with the International Space Station as intended, the Starliner spacecraft ended up orbiting the Earth about 33 times before it made a safe landing in the White Sands Missile Range in New Mexico on December 22nd. Earlier this year, we spoke with Leroy Kane, the Deputy Starliner Program Manager, about the mission. He says, knowing what they know now, had the same issue come up, but with crew on board, they could have reacted even faster than they did back in 2019.
So in some ways, it's fortuitous that it happened the way it did, because first we found the problem so we could fix it. And secondly, it led us to some other discoveries as we dug deeper post-mission into what we call RCCA, or the root cause corrective action. That led us down some other paths where we said, similarly, these other areas where we have critical timing, we want to look at those as well and make sure that we don't have any issues.
Boeing and NASA spent the next 2.5 years working to fully understand what had happened. During its fourth quarter earnings statement in late January 2020, Boeing noted that it was setting aside $410 million to conduct a second uncrewed test flight of Starliner, if that's what NASA wanted. An independent review team was also convened to study the anomaly and the best path forward.
My direction to the team was, we have to go look at some of the areas between here and landing where we have some similarly time-critical events in the software where there's handshakes between hardware, software, and firmware. And I need you guys to come back and convince me that we don't have any issues in those areas. It turned out we did.
Through the analysis of the jointly led NASA-Boeing Independent Review Team, or IRT, 3 primary concerns were identified from this first test flight. Number 1, an error with the mission elapsed timer caused it to be off by 11 hours, which means the spacecraft thought it was in the wrong part of the mission after separation from the rocket's upper stage. Number 2, there was a software issue with the service module disposal sequence that, if left unchecked, could have caused the service module to collide with the crew module after separation. However, a software patch was uploaded to prevent this. And number 3, there was an intermittent space-to-ground forward link issue, which made it difficult for the flight control team on the ground to control the vehicle and send it commands.
After we got back on the ground safely and we started to look more closely, it led us to ultimately a conclusion that we had not done enough what we call integrated hardware-software integrated testing in our laboratories. As part of our what we call V&V, verification and validation process, our requirements were to validate and verify a lot of our capabilities by analysis. Much of it by test, but many things all by analysis. And as it turns out, we decided by analysis for some of these things wasn't good enough. And we weren't happy with that anymore. And even though we were meeting our requirements, having done that, we took the extra steps to go add a lot more integrated testing.
As a part of the review, NASA also performed an organizational safety assessment of Boeing's work on the Commercial Crew Program. During a March 6 teleconference, Doug Lavero, NASA's then Associate Administrator for Human Spaceflight, discussed 61 corrective actions that Boeing needed to take. However, he stopped short of saying that a second test flight would be needed.
Will we require a test flight? Quite frankly, right now, we don't know. The findings and the corrective actions that Boeing has laid out, they have to now come back to NASA with a plan of how they're going to go ahead and address all of those. That plan will have a schedule. It will have all of the technical aspects to it. It'll have all the details of when and how they're going to go ahead and address them. And then NASA will evaluate that plan. We'll evaluate the results of their work. We will do our own inspection of the results of their work. And then we'll be in a position to decide whether or not we need another test flight or not.
In April 2020, Boeing announced that it would in fact be flying a second uncrewed demonstration of Starliner. We have chosen to refly our orbital flight test to demonstrate the quality of the Starliner system, Boeing said. Flying another uncrewed flight will allow us to complete all flight test objectives and evaluate the performance of the second Starliner vehicle at no cost to the taxpayer. In July 2020, NASA provided an update on an independent review of OFT. It gave 80 recommendations for both NASA and Boeing to address issues regarding the software and oversight of the review process. NASA officials reiterated the hope to fly OFT-2 in 2020, but it would depend on Boeing's readiness and the space station's availability. SpaceX, meanwhile, was preparing to fly its first operational mission in November 2020 after the success of its crewed Demo 2 flight in May of that year. By August 2020, Boeing declared it was making, quote, excellent progress towards OFT-2. The company said the mission could come by December 2020 or January 2021. But by the time December actually rolled around, Boeing announced that OFT-2 was pushing to late March 2021. In a statement, Boeing said, the company is more than 90% complete in closing out all the recommended actions developed by a joint NASA and Boeing independent review team, even those that were not mandatory, ahead of Starliner's uncrewed flight test. They also noted that, while this work was in progress, the crew module used on OFT was being refurbished, while a new crew module was being built for the crew flight test, which was targeting summer 2021 at the time. In February 2021, a new OFT-2 launch date was announced, April 2nd. The 8-day delay from March 25th to April 2nd came after a power surge damaged some of Starliner's avionics during testing. But in March, the launch date came under some uncertainty, and in mid-April, the date was pushed again, this time to the August or September timeframe. In a statement, Boeing said it would be mission ready in May if there was an earlier opportunity to launch. But they were challenged by the availability of the ISS, ULA's Atlas V launch pad, and the Eastern Range. As luck would have it, they were able to find that window of opportunity on July 30th, 2021, and now it was all starting to feel tangible. The Starliner spacecraft was rolled out of Boeing's commercial crew and cargo processing facility to meet up with its Atlas V ride to space. It was stacked on top of the rocket and rolled out to the launch pad, but then an issue with Russia's Nowcom module thruster on the ISS caused the launch date to shift to August 3rd. Prior to that, on July 29th, the then newly confirmed NASA Administrator Bill Nelson said the flight readiness review went, quote, smooth as glass. He expressed his confidence in the OFT-2 flight, while also saying why having two providers for the commercial crew program was always important.
Competition is good, not only for the obvious reasons that it brings about the most efficient, productive, and cost-effective work product, but what it does, it gives you a backup. The proof's in the pudding. Years ago, when this competition for commercial crew started, what if we hadn't had two competitors? And what if it had only been Boeing? And so right there, that's enough demonstration for you of why we want competition.
Trouble reared its head again for Boeing, though, when they encountered a valve issue in the Starliner service module's propulsion system. Teams tried to work through the issue while the rocket was out at the launch pad, and then again inside ULA's vertical integration facility, but both proved unsuccessful. Boeing made the call to return Starliner to the C-3PF on August 13th. In a teleconference with press in October of 2021, officials said the launch was being delayed until sometime in the first half of 2022 to allow more time to work on the valve issue.
We looked at the options of how to go forward, and we felt the best path was to proceed with the current service module. By keeping the same service module and crew module configuration, it's putting us somewhere in the first half of 2022. And, of course, that's pending spacecraft readiness, the availability of the Atlas V, getting a date on a range, and, of course, working with our ISS partners to ensure that we've got a port to dock.
Boeing noted that it was going to take some of the impacted valves to conduct thorough testing at multiple NASA centers, and they said it was unclear why they were having an issue now.
We have seen this propulsion system work successfully. It's the same propulsion system that we used during our service module hot fire, as well as our pad abort test, as well as OFT-1, and had not seen any of these issues. So there was no reason to believe that we would have a concern here.
Despite what Vollmer said in October, by mid-December, Boeing decided to take the service module that was going to be used for the crew flight test and instead move it up to the OFT-2 mission. The move would allow Boeing an opportunity to finally launch the OFT-2 mission in May of 2022. After extensive analysis, the company concluded that moisture got into the oxidizer isolation valves and caused corrosion. As NASA and Boeing finally approached the OFT-2 launch day, Mark Nappy, the VP and Program Manager for Boeing's Commercial Crew Program Office, said they'd done extensive work to understand and mitigate the valve issue, at least in the short term.
We do have root cause. We know that these nitrates, which are the type of corrosion particles that form inside the valve that made it stick, are formed through the chemical reaction of aluminum, which is the body of the valve is made of, the NTO, which is the propellant that we use, and some moisture getting into the system. So the trick for this flight was to eliminate that moisture and make sure that it doesn't cause those nitrates to form.
And with those changes in place,
and liftoff.
The OFT-2 mission finally launched on May 19th, 2022. And importantly, they were able to make it through the orbital insertion burn and begin the journey to the ISS. But as this was a test flight, some issues did crop up after spacecraft separation. 2
thrusters failed. The first one had fired. It fired for a second and then it shut down. The flight control system did what it's supposed to, and it turned it over to the second thruster. It fired for about 25 seconds, and then it shut down. Again, the flight control system took over, did what it was supposed to, went to a third thruster, and we had a successful orbital insertion.
The day after launch, Starliner made its approach and finally docked with the ISS.
It looked beautiful coming in, and it was just really special to get to see it come out there. And it was, once it parked out there on the doorstep for a little while, it was almost like it was just giving us a chance to admire it for a little bit longer before finally coming into dock.
After spending a handful of days on orbit, Starliner undocked from the orbiting outpost on May 24th and landed in the sands of New Mexico on May 25th, bringing OFT-2 to a close. In a post-landing briefing, Steve Stitch, NASA's manager of the Commercial Crew Program, described some of the similarities between OFT-2 and SpaceX's uncrewed Demo 1 back in March 2019.
We had challenges between Demo 1 and Demo 2 that people may forget about. We had a major redesign of the propulsion system between Demo 1 and Demo 2. I don't see that here on what we saw on this flight. Between Demo 1 and Demo 2, we did a redesign of the parachute system on Dragon. Again, I don't see that here on Starliner relative to these parachutes. We've worked with Boeing and done numerous drop tests. The parachutes perform fine.
Now, 2.5 years after its first orbital flight test, Boeing was finally looking at its first astronaut mission to the ISS, the crew flight test. After returning the OFT-2 Starliner spacecraft to the Kennedy Space Center in June, by August 2022, NASA and Boeing announced their intention of launching the crew flight test in February 2023. That was pushed back to April, though, in order to accommodate the ISS schedule for things like the docking of the SpaceX Crew 6 mission, the last of its original contract. The makeup of the crew flight test changed notably since Boeing astronaut and mission commander Chris Ferguson withdrew his name in 2020, citing family considerations.
I'm deeply committed to human spaceflight. I'm dedicated to the Starliner program, and I'm passionate about the team that has built her. But next year is very important for my family. I have made several commitments which I simply cannot risk missing. I'm not going anywhere. I'm just not going into space next year. The Boeing team has been very understanding. The crew is doing wonderfully, and thank you for your understanding too.
We'll delve more into the full evolution of the crew in our next video, but Leroy Kane said in the run-up to CFT, Boeing was moving into doing some great work with the final crew selected for the mission, NASA astronauts Butch Wilmore and Sonny Williams.
In that time frame is where we really ramped up the crew engagement. Our plan was always that we got about a year or 18 months before when we planned to launch CFT, we would have more regular flight crew engagement with the larger team. They'd always been there and working behind the scenes, but more engagement with the larger team to include a lot of these large integrated activities that we do, where we have the Boeing Mission Control Center, United Launch Alliance Control Center at the ASOC in Florida, the flight control team here in Houston, our mission support team here in Houston. We have these very large integrated activities that the crew was now part of.
At the end of March, NASA and Boeing announced yet another delay to the mission, this time to no earlier than July 21st, 2023. In his remarks, Steve Stitch said they were still going over the abort procedures, and he added that there was also still work needed to be done to validate the data for the parachute system on board Starliner.
At this time, there's really no issues or concerns with the parachute system. The parachutes are installed in the vehicle. They're in good shape. It's just a matter of going through all that data and looking at the data and making sure we're really ready to go fly safely.
He noted that they would also perform one last ground test that involves the chutes connected to the forward heat shield cover.
It is used to actually remove the cover off the very top of the Starliner spacecraft that then exposes the other parachute systems to deploy. And we're going to do a test at the highest possible regime that it could see in an abort part of the flight, and so we'll do that test on the ground, and just to make sure that system can deploy properly.
Fast forward to June, and another issue popped up, this time from one of Boeing's suppliers. In a statement, Boeing said, "We were notified by the parachute supplier of an issue identified through testing that reduced our safety margin. Our engineering team provided additional analysis, and given that, we determined the safest course of action was to stand down for the July launch opportunity." The announcement came on the heels of NASA's Aerospace Safety Advisory Panel expressing its concerns with the timeline. In its official minutes, the panel wrote that it is imperative that NASA not succumb to the pressure, even unconsciously, to get CFT launched without adequately addressing all the remaining impediments to certification. In a June 1st teleconference, Boeing officials said 2 issues were found late in the verification process. The first had to do with the so-called soft links of the parachutes, and the other was an extensive amount of flammable tape found within the spacecraft.
We found them because our process is rigorous. We found them late because those elements of the process, by definition, they come at the end of the process. So that's just the way it works. Nevertheless, the lateness doesn't ever make you feel good.
All these delays over the years not only impacted the potential astronaut flight schedule for NASA, but also Boeing's bottom line. After the valve issue was discovered back in the summer of 2021, Boeing's Q3 financial statement noted a $185 million hit from the Starliner program. Stacked on the original $410 million estimate to fly out the OFT-2 mission, that brought the overrun to $595 million. During the 2022 Q2 earnings call, Boeing noted a $93 million charge, quote, primarily driven by launch manifest updates and additional costs associated with OFT-2. The total cost now ballooned to $688 million. The trend continued, though, following the 2022 Q3 earnings call. A filing with the Security and Exchange Commission pointed to another $195 million loss, reflecting increases to estimated costs related to completing the crew flight tests. Losses now stood at $883 million. By the time the latest announcement of delays came, related to the flammable tape and the parachute concerns, Boeing's 2023 Q2 earnings statement reflected another $250 million hit. That brought the total to more than $1.1 billion in delay-related losses. During an update on August 7th, 2023, NASA Steve Stitch sounded optimistic about the progress made to address the tape and parachute concerns. He noted that a number of independent review systems had also been put in place. An independent team within Boeing to look at all the areas that were previously closed out, NASA's chief engineer re-interviewed every subsystem manager, and NASA's chief engineer, his deputy, and the head of the NASA Engineering and Safety Center all worked with technical experts to review the major issues still remaining for flight.
We did brief this plan to the Aerospace Safety Advisory Panel last week, and they were pleased with our plan of independent reviews, and they felt like this was exactly what we wanted to do on the NASA side, the Boeing side, and then as also pointed out by the Aerospace Safety Advisory Panel.
During that teleconference, they announced March 2024 as the new CFT target date. By October 2023, NASA determined that actually April was a better month for the ISS schedule. Leroy Kane said, to tackle the parachute issue, the team decided to move up the parachutes originally intended for Starliner 1 to instead be used on the CFT mission. In early January, NASA and Boeing conducted a final drop test to validate the adjustment.
Back in the fall when we made that decision, we already put the steps in place to ensure that we would then have the next set of chutes, which will now be for Starliner 1, and they're not even on the critical path for Starliner 1 in 2025.
Boeing also managed to remove about a mile's worth of the problematic tape from within the spacecraft, or otherwise negate it as an impacting factor. And now, in May 2024, Starliner is once again back on top of an Atlas V rocket. It is finally poised to launch the first crewed mission roughly a decade after its selection by NASA to work alongside the SpaceX Crew Dragon. And as for Kane, a man who worked with the shuttle missions going back to STS-26, the return to flight following the Challenger disaster, the weight of this crewed flight test is very much within him.
The hardest thing to do is get that first inch off the ground. And I know how hard that is. Even now, when I watch missions that aren't ours, but that we're interested in because we're involved, even if just tangentially, when I watch spacewalks, I mean, it makes my palms sweat. That'll never go away for me. I know too much. And so that's part of what you just have to understand. That's required in this business. And if you don't feel that way, then you don't understand it well enough.
Be sure to stay tuned for part 2 of this 2-part series, in which we'll introduce you to the crew in full of the CFT mission, the training that they had to go through, as well as talk about the full mission profile in its entirety, from liftoff to landing. And until then, for Spaceflight Now, I'm Will Robinson Smith. We'll see you on the next one.